Welcome everyone in the next session of pavement or road history and where we are standing in the 21st century. So what type of modification have been done so far? You can also follow this channel for the pavement design as well. The road construction was considered one of the most ancient human activities. So the human society has early understood the importance of constructing road network because they understand that the opportunity to of the dynamism to make the people dynamic rather than static is the only possible through transportation. While road network or the construction of road was one of the essential part of the same era. We will trying to understand the Roman Empire, that what they have done, what type of activities was did in the 17th century, and we will try to understand the wheel concept as well. Okay, as maybe some of you are aware of that the invention of vehicle gave in the a very enormous impulse to the development of the road engineering, because a different type of a binder material such as bitumen, concrete, and so on have been uh, derived at the same time. So today the very modern construction technique must also confront the factor such as environment friendly energy consumption, health potential effects, and also to introduce the nanomaterial as well. So all those are the part of the pavement history. If we try to understand the pavement history, so it is very much important, first of all, to understand the history of a wheel. So early wheels were quite simple. They were usually constructed from the wooden desk with a hole, okay, at the middle edge, at the very middle. So some of the earliest wheels were made from the horizontal slices of the tree trunks because of the uneven structure of those woods. So they usually try to construct it from the different slices. So the first wheel was invented in 3500 BC in Asia. Okay, and the roads begin, or the moment, if we try to connect it with the Egyptian history. So basically, wheel was invented at the same time. If we talk about if you try to understand it, when exactly the long distances highways were actually built, so you can imagine that the time of the Great Persia in the year starting from 323 BC till 3500 BC. So the first road was built among the same era, which total distance was 1755 miles, and this to cover that journey it almost took 3 months. So you can imagine that where we were standing, or our forefather were standing before. Now, if we talk about the first engineering road, so the first road was recorded uh, by the almost 3000 BC, from the time period where they first of all used the asphalt is the binder material with other precious and different type of a stone to increase its stability. It's to also prevent that from the waterlogged surfaces, and also to provide the waterproofing technique as well. And they also came up with the cementitious type different materials as well. So the first road in the first engineering construction, it was constructed for about 5,300 miles. So you can imagine that it almost have been 200 years. So they only came up with the two idea, dry road bed or the impervious surfaces. So the oldest Roman road are still in use today. As you can see here that in that specific figure, um, that in 300 and 312 BC, so the Roman network consists over 6,200 miles by road, and they have different techniques of the maintenance as well. Is also they introduced the basic system which they are still using in the United States today as well. Although Roman roads did not use asphalt as a binder, okay, but they did often use lime grout and other natural pozzolans material, okay, in the typical Roman road construction. As you can see here in the very first picture, they have different size of a squared and the dry stone at the very lower level here, and then they have different size of a stone at each and every level at the radius as well as at the nucleus, and the top surface was a bit grooved and the in the curved because for the drainage to increase the drainage capacity. But the only issue with that specific road were because they did not have the enough drainage capability. Is you can see here at one side they have the type of a small drains, but because of the binders, because of the lacking of the binder, so those roads were constructed at that time and were considered as one of the first engineering road according to, if you can have a look with the recent techniques. So of if of course they have squared stone, they have dry stone, and the thickness of each and every layer was quite high, like far, like almost 400 so it's consist of a massive labor work, so you can imagine. The first road was built in France, Trasgut, where they have too much labor cost and they come up with the smaller stone in the thinner section. So the first modification was done in France in the middle of 17th century, and it design almost took 10 years to like modify that, but it's the total design life of that specific pyramid was about 10 years. As you can see here that they use different type of stones across the whole curve section. The only difference between the Roman road and the first modern road, because they came with the completely curved type of the construction, and they also use the specific type of those stones at a very unique and specific sections. And also all those small stone were of the size of the walnut, so that they can penetrate or restrain the environmental effects such as water, so that it cannot it should not touch the lower surface. If we talk about the 18th, 30th, so the first road was constructed from the tar and asphalt, which we called nowadays macadam. A tar macadam road consists of a basic macadam with a tar bound surface. It appears that the first tar pavement was placed almost in the 1900 and in 1848 or in 50. So at that time, such pavement were considered suitable only for the light traffic. And but if we talk about the to use it for the heavy type of traffic, so those stones may not work. And if we talk about the road construction, so we've been through different stages. So 1850, the first Portland cement concrete was built in Austria, but due to its weak stability, it did not sustain for a very longer time. And then we had in 1900 the rubber tire motor cars, which basically caused too much dust and pollution problem. And also we were looking at the time of researcher was still looking for the binder so that they can reduce the dust and pollution. And of course, high speed requiring more smoothness. So with the increase in speed, so the same dust and pollution issues were also increasing. In 1920 in US, the Highway Research Board were introduced, which is now what is called the TRB, Transportation Research Board. So there were researchers who made and put a lot of efforts to improve the pavement design. They hunt for the binder material, and also they introduce the different rapid development and the different maintenance strategies as well. So at the starting of the 20th century, so nowadays we had a better understanding of the stress, strain, deterioration concept and load distribution and stresses distribution. We almost end with different binders, so that what type of binder we should use in like which type of a surface. And we also introduced it how we can use different binders to reduce the pavement thickness and so on. So coming to our first topic, which is called it where we are standing now. So those are the development. Basically, the pavement, you need to understand that what is pavement. Excuse me. The pavement structure is actually the combination of a base, subbase, and subgrade. Okay, which is placed above the Earth's surface on the subgrade to support the traffic load and to distribute it to the lower supporting layer. So this is the definition of the pavement. As you can see here in this structure, we have the pavement should consist of the shoulder, and there should be different type of binders at each and every layer, and each and every layer will be different according to the load parameters. So the primary function of the pavement should be to transmit the load to the lower area, while the more flexible pavement contains maybe sand and gravel or like type of a crushed stones and the different compacted binder and so on. And the purpose of the pavement should be to reduce stresses, okay, reduce the stresses at the very good level, and also those stresses should equal to zero before reaching to the subbase and subgrade level. Number one. The second is it should prevent the settlement or which we call the abrupt collapse. And also there should be type of a construction ways through which we can remove the water from the so like within that pavement structure, there should be a capacity, there should be a mechanism which should not allow the water to stand there for a longer while. So there should be a self-constructed capacity that it should run off this water from its surface. So in the 20th century, now we understand that the pressure from the wheel develop in the form of a stresses in the different material layers in the road construction, which basically uh, kind of the bending of the same slab due to traffic load to develop stresses within the pavement. So now we are almost reached that the stresses under the dynamic wheel load should be divided over a large area. Now we are able to understand and we can determine the different type of stresses at any level. And we can also distribute the and derive the vehicle stress distribution along the horizontal as well as the vertical axis. So this is now the 20th century, and the same stresses could be increased or decreased with the increase and decrease in the stiffness as well as the thickness. Okay, and this is the very basic definition that subgrade stresses and strain where they are trending. So the first thing you need to understand that we will always have the maximum stresses at the top layer, but those stresses and strain will reduce with the thickness. So, but those stresses should make sure the design of the pavement should make sure that it should leads those stresses and strain before reaching to the lower layer. And if those stresses did not reduce with the while reaching to the subgrade level, so then we might have issues. Okay. This is the typical modern system. So in the pavement type, we have two different type of the pavement. One is flexible pavement, while another one is rigid pavement. So in the rigid pavement, we have two basic types. One is called jointed plain concrete pavement, while another one is called CRCP, concrete reinforced concrete pavement. So there is a slight difference between both of those two types, but its core function is because we use rigid pavement for the heavy loading, for the heavy dynamic as well as the static loading. So the jointed plain concrete pavement use basically those joints, which we call the construction joint, to control the cracking so that and we usually did not use the steel in like those joints, but we use only the dowel bar and tie bar. And also we would like through our design, we try to reduce the transverse as well as the vertical movement so that under the temperature and moisture stresses, it should not produce the quick or the intermediate cracking between those joints. So this is the reason that we introduce or use the dowel bar, and the tie bar for the load is the load transferring agents. As you can see here, the aggregate interlocking between those two dowel bar is basically used for the low volume road aggregate where the interlock is often adequate. So however, the high volume roads generally require dowel bars in each transverse joint to prevent excessive faulting or the deterioration. As you can see here in this very specific picture, so those two slices of the same road are connected in two different shapes. This is the reason that we called it the jointed plain concrete pavement. The next topic, the type of the rigid pavement is we call that CRCP. Okay. CRCP is basically a type of a concrete pavement which does not require any transverse cracking joint, but we provide those reinforcement throughout that series. Okay, here, and we do not have any joints, and the CRCP always makes a good option to choose for restructuring for the restructuring uh, of the or the selection of the CRCP whenever we have the massive loads. And then we have two different type of a rigid pavement. One is CRCP, while another one is PCP, which we call pre-stress concrete pavement. So the pre-stress concrete pavement is basically the efficient and lasting solution for the rapidly building and construction of the massive highway, which usually offer faster project schedule, less labor usage, and also improve the safety as well. And it's also have the shorter worker window as compared to the construction of those worker as compared to CRCP. Thank you very much. If you have any question, please get back in the comment section.